I'm back.
Boom. All right. All right. Thank you all for joining, and I will let Ben kick off this episode of Merge PHP, and then we'll go through the Austin stuff as well. And I will switch over to camera mode here because we are. Host has stopped video. Yeah, we'll just leave it. All right. Yeah, we're streaming live from Longhorn PHP conference here, put on by some organizers of Awesome PHP User Group. So go ahead and take it away, Ben.
Well, we can't see your video, Ian, if you're trying to turn on video.
Yeah, I'm working on it.
All right, cool. Yeah, thanks for joining us for October Merge PHP. This is a joint meetup between Atlanta PHP, Boston PHP, and right here in lovely Austin PHP. We're live from Longhorn PHP Conference, the first in-person conference in the US, I think, in like 2 years or so. So it's kind of wild. It's great, and yeah. Sorry for the tech difficulties. We know they're live streamed before. Hopefully, it's worth it. Chris, do you have intro slides you want to do? You want to start us off?
Okay, sure. We'll do a quick share here. Maximize. Share, hold on. Full screen, and then that went away. Where is that screen? Here we go. Stuck in full screen. Hold on, I'm trying to get back to where I can share the right thing here. Sorry. Here. Okay. Okay, well, thank you all for coming, especially live people in Austin at Longhorn. Appreciate everybody being here. Just a quick bit about us. I think most people know me, but if not, I'm Chris Spruck, lead organizer of the Atlanta PHP User Group. Real quick, just want to mention our video sponsor, veryx.com. One of our long-term members, David Edmondson, has a Magento consulting and development shop. He's been a long-time supporter and member of the group, and has been our video sponsor for a couple of years now. So we just like to recognize him and his efforts. You'll see where our video archive for all our meetings are coming up in a future slide here in a second. Here at our non-meetup site, atlantaphp.org, we have a Google group for discussion and job posting. And as I mentioned, our video archive, we've got going all the way back to 2012. So you can go back and see our prior meetings. I think Ben was one of our first couple of, Ben Edmonds here was one of our first or second captured presentation back then. So you can go check him out if you want to see what he looks like 10 years ago and 9 years ago. You can go look at that one.
Few less gray hairs.
Yeah. Also, Atlanta's in the JetBrains user group program, and every month they give us a free license to raffle to any of their IDEs, and you can attach them to an existing subscription if you already have one. So and I have a one left over from previously where I forgot to give it away. So the first two people to email chris@atlantaphp.org that are listening in, I will send you the license info. They do expire, so if you get one, please make sure you use it quickly. And I think that's all I've got for now. So thank you all again very much.
Thanks, Chris. Ian, do you want to do any kind of intro for Austin?
Sure. So, hi there. I am representing Austin PHP User Group. Ian Littman here. Logan Lindquist would normally be in this position, but he's out due to some health stuff. I think we're the longest running PHP user or longest running tech user group here in Austin. It's been quite a while, and since I'm not usually one organizing, I'm not even going to guess at how many years it's been, but it's been well over a decade. We have had these online meetups for a bit now, probably about a year and a half, at either Austin PHP or as part of Merge PHP. And now we're doing this thing hybrid here at Holiday Inn in beautiful Austin, Texas. Well, it's kind of gray outside right now, but bear with us. And here at Longhorn PHP Conference, which it's exciting to be able to put on an in-person conference for the first time in quite a while. Yeah, we've got a Slack group that we're hanging out at. It's austinphpchat.com if you want to hang out there. And that's not just for Texas-based folks, but I think that's basically it. So I will turn it over to our speaker for this evening. And Ben, you want to go ahead and introduce him?
Yeah, definitely. So very excited to have with us tonight a speaker from the EU. So I met Mario when I was over in Serbia at Serbia PHP. Great guy. I'm really excited for you to hear from him tonight. He's going to tell us about living with open source responsibility. So I'll turn it over to you, Mario Blazek. Thanks for coming on.
Hi, everyone. Thank you very much for inviting me. So hopefully you would enjoy my talk. Just give me a sec to share my screen. Okay, can you see my screen?
Got it.
Okay. So I think we can get started. Okay, so how often have you asked yourself how much effort is required to create an open source package? How much effort do the open source maintainers put into the maintaining their open source projects? How many times have you asked yourself what I need to do to create my own open source project? Should I only push my code to the GitHub, and would that basically be it? Would be enough? Would actually someone use my project? Well, in this talk, I'm going to provide some answers to some of these questions. So basically, it doesn't matter if you are coming from or going to a community that's based around an open source language like PHP. If you check a Microsoft community, for example, you will see that they are also open sourcing quite a lot libraries and packages lately. So basically, we can say that open source is ubiquitous. Basically, there is no community out there that doesn't do open source, or at least some small, tiny thing. There are even companies out there that base their businesses entirely around open source. So about me, my name is Mario. I work as a backend developer at Q Agency. It is a Croatian agency based in Zagreb. We usually do API backends and mobile apps, and we work with the clients from all around the world. You may ask the name Q. So Q got the name from the James Bond movies. It was inspired by the Q branch that built some very cool and ahead of its time gadgets that saved Bond's life in so many situations. My full-time focus is a startup project called Gens, where I lead a team of developers. Well, Gens is a communication and a feedback platform that serves as a modern internal social network for companies. And it gained a lot of traction lately, especially during the COVID-19 thing, the COVID-19 pandemic. I'm married. I have 2 sweet sons, and I strongly believe in open source, which I try to promote as much as possible as one of the organizers of Zagreb PHP meetups. And they call me a chief fire officer because I volunteer as a fireman at the local fire brigade. Okay, so let's get started with building an open source project. So the story of how I got into the open source is this, or maybe I should rephrase that. The story of how I created my first quality open source package goes like this. So I did some stuff before, but it was just for fun. So back in the day, I was developing solutions on top of Easy Platform, which is like a Symfony-based content management system. And one day we had a requirement to build a form system that can be controlled from the back office, from the admin interface, basically. So the similar solution already existed in the Easy Platform version that was like more than 10 years old, and no one wanted to use it. So I decided to write the new one on top of Symfony. The solution worked rather well, and but the mistake I did, I left the solution in the project's code base. So immediately after, I started working on another project, which again needed some sort of back office form control. So I realized that the similar solution was already developed on a previous project, and I decided to just copy and paste the code. And this was a rather stupid solution. Who wants to copy and paste the code all the time? So I said to myself, it must be a better way. Why not to build some sort of reusable solution that can be installed when needed, right? I was thinking, why wouldn't I create an open source package? Maybe someone would benefit from it out there. Plus, I wanted to gain some street credibility in the Easy Platform community. So at first, it was pretty much scary. I thought that this package would be a laugh. The question that popped into my mind all the time was this: who would use the package that I've built? And basically, this picture popped into my head all the time. So all the other more experienced developers looking at me and they're saying, okay, open source, are you crazy? Well, what's the matter with you? But I firmly believed that if this package solved the problem for me, and basically it even continues to solve my problems, that it will work for someone else. And basically the rest was history. And this is what I've learned as the maintainer of the open source package. First of all, start small. Don't try to cover all the possible cases that pop into your mind, because you will just start spinning around and you will end up nowhere. You will never finish your project. So for example, in my case, the CMS that we were using, it had something called field types. And from basic text lines to more advanced XML-based text editors, whatever. And in my first release, I have covered only the text lines and text area field types, which was enough for me, basically. And most of the time, we were building like contact forms. And basically now, when you have like your own MVP, just stop adding features and focus on code. So before going outside, and by outside I mean to the public repository, try to clean up code as much as possible. Try to follow solid principles as much as possible. And I'm not going into detail here what solid stands for, because it's just out of the scope of this talk. And there are plenty of resources about solid, especially videos by Stefan Pripsch, or for example, Tobias Schlitt. They have like an awesome teaching style, and I suggest that you check their videos about solid. Tests. Again, there are many resources about writing tests. I'm going to say you should write tests, period. You don't have to achieve like 100% code coverage, but just try to cover the most critical parts. These are some available libraries. for example, from PHP unit, which is like de facto standard in PHP community, to PHP spec, or if you are coming from like a JavaScript, if you're having like a JavaScript background, then for example, you might want to look into colon or period because they have like a functional style of writing tests. And you have PEST, which is like a new kit on the block. I didn't use it myself, but as you can see, there's a lot of hype going around recently. So I suggest checking it out. It is on my to-do list. Okay, let's move on to tools that can help you maintain a high quality code standards, basically. The tools like PHP CS Fixer or PHPStan, they're pretty much useful, and we're going to check them more in detail in the following slides. Those tools are meant to be installed locally on your machine so that you can fix the code before going onto public repositories. So before you commit your changes, you run those tools, fix the code, and then push the code to the public repository. Okay, so PHP CS Fixer or PHP Coding Standards Fixer is its full name. Well, the idea is very simple. You just create the configuration file called .phpcs. You put all those coding standards you want in that file and just run the PHP CS Fixer, and it's going to fix all the coding standards on your project. What's good about it is that you can commit that configuration file into repository so that all other contributors to your repository can actually share your coding standards so that they can comply to your coding standards, which is extremely fine. So the next tool that I have in line here is a PHPStan. PHPStan is a static analysis tool. And as you know, PHP is not a compiled language. Basically, it is compiled, but we don't have some compiled checks. We need to run PHP code to actually see some errors. But with PHPStan, PHPStan is basically replacing a compiler's role in statically typed languages. So basically, it checks for the existence of variables, type hints, return types, some useless castings, etc. And it can catch extreme amount of errors, so I definitely suggest that you try it out. And it can be safely installed per project. Just create the configuration inside phpstan.neon and run the PHPStan. PHPStan has, I think, 8 levels of strictness. So start with the lowest, like a level 1, and move to the level 8. And you will see some interesting facts about your code when PHPStan starts to analyze your code. Another cool project that I have installed here is Psalm. Psalm is another static analysis tool. It is developed by Vimeo, and it's got its own peaks and perks. I like them both, PHPStan and Psalm, so I'm using them both, but I definitely suggest that you running one of them is perfectly fine on your project. Both of them will do extremely good job, so just select one and stick with them. Stick with it. The next tool that I would like to introduce you to is the Reconstruction tool, or the rector for short. It is extremely good tool because it provides automated code upgrades. By automated code upgrades, I mean by, for example, imagine that you have like a pretty much old project that is stuck with PHP Unit 4 version, and you want to upgrade PHP Unit to PHP Unit 5, 6, 7, 8, 9, blah, whatever. And in PHP Unit 8, for example, there was quite a lot of deprecations, quite a lot of changes, and you would need to go to all your test files and update the syntax manually. But with the rector, you just select the plugin for the PHP Unit 8 and run the rector, and it's going to automatically update syntax of your tests, which is perfectly fine. And it's got like something like 450 vectors available, for example, for migrating to PHP versions, migrating for tweak 1 to tweak 2 from some framework to another framework. For example, I think they did like a migration from one framework to Symfony in like few minutes, which is amazing. Especially they have like an example migration from PHP Unit 4 to PHP Unit 8 in seconds, which is extremely fun, especially when you need to maintain your library. You don't want to do repetitive tasks all over again. So I definitely suggest that you take a look at Rector. There are even more tools available online, but we don't have time to actually go into detail for all of those. So I definitely suggest that you take a look at Infection PHP, which is mutation testing framework. It modifies your test code and it tries to break it. So it finds even more errors, which is interesting. And you have like a another tool is PHP Insights, which actually scans your code and calculates the code quality of the code and generates like reports. You can see like code complexity, cognitive complexity, pretty much quite a lot of useful information, and it can even give you the insights what to improve, what's bad, what to improve. Then another tool is that I have here is a DebTrack. DebTrack is a tool that is creating a dependency graph of your code. So for example, it is extremely good, a nice way to spot a coupling, especially if you are doing some sort of domain-driven development, and it is going to create a graphs where your domain layer is, for example, or infrastructure layer going into domain layer. So you will see all the dependency graph, and you can see which parts you need to decouple in order to your code be more to be less dependent on the infrastructure code, for example. And we have like a PHP mess detector, which is pretty much tool that's for like I think like 15 years it's outside. It's like an old tool, but still works like charm. Okay, so let's move on to continuous integration tools. So tools like Travis CI, GitHub Actions, Scrutinizer, and Code Coverage. Let's see what they have installed for us. So those tools are offered as a service, so you don't install them locally on your machine, but they are provided as a service in the cloud, basically, and they all have the integrations. They'll provide integration with GitHub. So the idea is that on every push to your public repository, those services, they trigger some predefined jobs that you define in their configuration files. And what can you do? Let's see next. So for example, Travis, the first tool that I have in line here is, it was basically de facto standard for GitHub-based repositories. So every single open source project used Travis. But the guys from Travis, they decided to shut down the free service, travisci.org. And they basically started to losing traction because they were completely free, and they just, I think they have like 100 minutes or something like that of build time. And so basically people just started ditching Travis and switching to some other tools. The idea of Travis is very simple. You just create a .travis.yaml configuration file. You put config inside that file, and I have a example configuration here. So here, for example, we want to run a tests for two PHP versions, PHP version 7.2 and PHP 7.3. And basically we are installing dependencies, running tests, and then we are doing some some things on success, but these things are not important for now. And if we push the code on our repo, the end result is going to be this. We'll see two runs, PHP 7.2 and 7.3. And for example, we have an error on PHP 7.2. We can click on that and see what's happening behind. Okay, now we can see the error log, and our package is not compliant with 7.2. Okay, so perfectly fine. So you can see all those. You can run the tests on every single push to remote to public repository, which is extremely fine. And you can run on every, for example, when pull request is created, Travis can be ran, and basically you can configure Travis on whatever you want. It's a powerful tool, but sadly they decided to limit it to 100 minutes of build time, which is sad. Another tool that gained traction lately, basically when Travis started losing traction, the GitHub Actions just popped into life. And GitHub Actions is provided by GitHub. It is integrated automatically by default, and it's free for all public repositories. So you add your configuration to .github/workflows directory in YAML files. I have an example here. So here I'm running a static analysis, PHPStan, PHPStan tests, and solve. And if I go to GitHub, I have a tab called Actions, and I can see, okay, static analysis is there. Okay, let's click on static analysis. I can see 3 jobs completed: PHPStan, PHPStan tests, solve. Okay, let's go more in detail to see PHPStan. So I'm going to click on PHPStan. It is displaying me a console. Okay, it is doing composer update, blah blah blah. Okay, it's running PHPStan. Let's click on PHPStan to see the end result, and we can see the PHPStan output. Okay, and pretty much you can do whatever. You can run tests, you can run static analysis. There is quite a lot of things that you can run in the CI. It's pretty much powerful tool. Another tool that I have in line is Scrutinizer CI. Scrutinizer can do all those things that Travis can do and GitHub Actions can do. Plus, the one thing that it can do, it can create a code, it can generate code analysis reports, which Travis and GitHub Actions can't do. And this is good because it can run a CI pipelines, plus it can generate a code analysis reports. So for example, you create a configuration, you put your configuration into .scrutinizer.yaml file, push the code on the public repo, enable the integration, and basically that's it. It's going to track the code quality of your code periodically. So it looks something like this. So for example, I pushed one commit. I can see my class, my methods in that class were added. It says, okay, I have introduced one issue, and it suggests, okay, I have one new patch that is available, and it's telling me what I need to do to actually apply that patch. Here is a view of some of my classes. As you can see, you have a rating of your classes. You can see the coupling, cohesion, size, complexity, pretty much useful info, and you can go even more in detail. For example, if you click on one of those classes, it can, for example, suggest you some improvements in say code. For example, here I have a catch block which is empty, and it's telling me, okay, consider adding comment. Why do you have like a empty catch block, which is not good. And the best thing, it can generate like a overall score of your library, of your project, of your framework, so that you can track, for example, overall progress through time. And the final tool that I have here is called codeconf.io. Basically, codecover.io is something like a PHP units code coverage report, but on steroids. The whole reports look pretty much very neat. You know, they're styled. They're very fancy. It is important to notice that CodeCov cannot generate code coverage on its own. So you need to add the code coverage results to, you need to upload the code coverage results to CodeCov, and then it just visualize that report. So here is an example. I have like a few classes. We can see coverage report for those two classes. And if I click on one of those, I will see like a detailed view of my class, and it's going to display all those lines in the class, and it's going to mark the lines which are covered by tests, which is pretty much very neat. And you can configure it to calculate the code coverage. For example, when someone creates a pull request, it's going to report, okay, this pull request is going to downgrade your code coverage by 2%, or this is going to increase the code coverage, which is perfectly fine, you know. Okay, and we have even more tools, but I didn't have time to actually go through all of them. We have like tools like Code Climate, Circle CI, and most of those tools are like they will work only on GitHub. But if you're, for example, hosting your code on Bitbucket, then your only option is Bitbucket pipelines. Bitbucket pipelines, unfortunately, is not free. You have small amount of time that they offer for free, and you need to pay for the complete service, unfortunately. If you are using GitLab, they have something called GitLab CI, which is, I think, completely free. So if you are on GitLab, you're basically fine. You have your own CI service. Okay, so we covered the tools. Let's go to the second part. Okay, the documentation. So the documentation is one of the key aspects of the great software. It improves the overall package quality. So you, as the author of the package, you should tell the other developers how to use your code, your library, your project. You need to teach us how your piece of software is meant to be used. Because I don't want to dig into the source code every single time I'm installing a new library. It is fine if I need to debug something or for learning purposes, but just to get it going, it's not okay. So try to document the installation procedure, configuration, use cases, some extension points, and upgrade guides. That would be perfect. Well, usually having a documentation in Markdown files is perfectly fine. You can either logically separate documentation into smaller Markdown files, or put the whole documentation into a single file. Both approaches are perfectly fine. But to level things a bit, I suggest checking some of the available documentation systems out there. They are here to help you build, version, and even host the documentation for you. And migration from Markdown is pretty much very simple because all of them support Markdown. Personally, I like read the docs. It is based on Python, so it takes a bit of time to set it up, but once you get it going, it will serve you pretty much very well. And this is how it looks like in my case. You have like a big pile of themes to select from, you know, like it's like a quite a lot of themes if you not like the default scheme, for example, and all those things like a menu, like links between pages and contents list, they're automatically generated by the read the docs. So you just need to put the content in the files, and basically that's it. Just run the read the docs and that's it. I have included a link to my blog post where I have documented the whole process of installation and configuration of Read the Docs. So feel free to check it out. Okay, so we are done with the documentation. Let's cover another aspect of great software, which is licensing. So I suggest you choose a proper license. It will possibly save you a lot of headaches in the future. Your project will definitely look more appealing to other folks that plan to include your code as one of the dependencies for their projects. And this is especially important to parties providing the enterprise software, because they would check your license. And so the most used ones are Apache license, the MIT license, and GPL in version 3. The MIT license is very permissive, and GPL is like the least permissive, and Apache sits somewhere in between. If you're not sure which license to use, there is a website called Choose a License, which documented the big list of licenses, and it can help you with the adoption of a proper license. Definitely take a look. On the other hand, if you don't care about licensing, but you want to have a license, you can either select the unlicensed license, or you can use the do fuck you want to public license. It is very permissive, and it allows the users of your code to actually do whatever they want to, even to sell it. And I have included a link to blog post, which is interesting. The Elastic blog, where they elaborate their switch from Apache license to actually their own Elastic license. Well, the problem was in 2015 when AWS started offering a service called Amazon Elasticsearch Service, and they did not consult Elastic for that. They just pegged the Elastic and start offering that, which is kind of not cool. So this is why choosing a proper license is a must. Okay, so moving on. Another important aspect is how you will version your code and publish releases. Before drafting a stable release, it is important that you define something that's very popular among the developers, and it is called a public API. So what is the public API? It is the part of the code that the users will interact with, basically. For example, let's say that you're building a client that is fetching the weather forecast through the Open Weather Map service. And you will probably create a lot of utility classes, helper classes, factories, etc. And you will have a service that's got a public method that accepts a city name as an argument and returns some sort of weather forecast object back. This service and its public method is going to be your public API, because everyone who wants to fetch the weather forecast will use the same service and method. That's why you need to be careful and not to break the behavior of that method in the future releases. And this is where the semantic versioning, or SEMver for short, kicks in. So for example, this number 1.0.0 is an example release. So please ignore the label for now. So the first number on the left is a major version. This number must be increased every time you introduce if when you introduce a backward incompatible changes. So let's say that fetching a weather forecast by a city name that you had previously is not enough, and you have decided to change that method, and that it now accepts the geographical coordinates instead. And basically this is a breaking change, and you must increase the major version, or you will just have like a bunch of angry developers screaming at you because you broke their software as well, right? So the second number is so-called minor version. It is increased every time when you add a new functionality that does not break the backward compatibility. Again, in our case, when we add another method, so now we have two methods, we have another method that actually fetches the weather forecast by geographical coordinates. So the old one still works, and we added a new functionality. So we have a lot of happy developers and new features. So everybody is going to be perfectly fine. And finally, the last number, the third number, is a patch version. So this number must be increased when a bug fix has been provided. But again, the backward compatibility is still preserved. Okay, this looks a bit daunting for now, but let's see a Git strategies that can help you cope with this. The Git strategy that I have here, I'm calling it a flat model. It's something that I used in my open source projects. It's a simple model, and it's perfectly okay for simple open source projects, for simple projects. Basically, the idea is this: when you tag the first stable version, so after when you tag like a stable version, you create a branch for that release. So for example, 1.x release, which represents 1.0 release. And so, for example, you start adding commits, one commit, first commit, second commit, and then you tag, so those are new functionalities, and you tag 1.1 release. And then after that, you have like a new, you have like a two commits for bug fixes, and then you need to tag like a bug fix release, and you need to tag 1.1.1. The problem with this is that you can't go backwards and support like something like previous versions. In this model, you need to always like move ahead. So for example, if you are on release 1.2 and you create like a two bug fixes, you need to tag 1.2.1 release, which again is perfectly fine for simple open source projects, but for complicated ones, this wouldn't work, because you are unable to actually go back and provide a support for some previous versions. And in that case, this model comes in. So for example, for every single release, we have a release branch, and in any point in time, we can just go back to some of these branches, do something, and tag a release. For example, imagine that someone reports that they have a problem with 1.3 version. So we have one of our users, they report that, okay, the release 1.3 dot something, they have got some sort of problem. Okay, and so you as a maintainer, you need to analyze, okay, so what is the lowest version that is affected by that problem, by that bug? And you start analyzing and you see, okay, the user reported the version 1.3, but my bug is actually introduced in version 1.1. So you as the maintainer, you need to go back into the version 1.1, into release branch 1.1, provide a bug fix on that release branch, and you always merge upwards. So you merge 1.1 release branch into 1.2 release branch, and then you merge 1.2 release branch into 1.3 and 1.3 and 1.x and etc. So you are always merging upwards. So in this way, you are able to go back and, for example, 1.1 release and provide a support for that release. And if you go to, for example, to Symfony GitHub page, you would see that they're also doing the same thing. They are creating like a release branches for every single version. And if you take a look even closer, you will see, okay, that they are doing the same thing. They are merging 5.0 into 5.1, for example. 5.2 is then merged into the 5.1 is merged into the 5.2. And 5.2 is merged into their development branch, which at that time was 5.x. Meanwhile, they released the 5.3 version, as you know. So this is kind of looks complicated, but after some time and after some practice, it's pretty much becomes very easily. But as you can see, Symfony does it rather well, but usually you will probably end up with something like this, right? Something that is trying to follow somewhere, but it's not going good. But practice makes perfect, right? Okay, so the next thing I would like to cover is the changelog. And the changelog is a file that contains a curated, chronologically ordered list of notable changes for each version of a project. And I've seen projects where maintainers show like a big list of commits between versions. Well, that's not a proper changelog, especially if you have like a big release, and just skimming through the list of commits can be pretty much very daunting. And there is no chance that you're going to find what you're looking for. For example, you're trying to check what happened there, but you probably miss it because there are quite a lot of commits. And especially if people are not writing like a meaningful commit messages, you'll probably not find what you're looking for. So it's going to be, you would need to use git bisect actually to find something, which I suppose that you don't want to use. You want to do that. And basically for that purpose, the project keep a changelog has been created. It defines like a structure of a changelog file, and where everything is separated in nice and clean order. And it can be easily spotted what was added, what was removed, what was changed, etc. So when you open changelog, you can see directly what was changed, what was removed, added, etc. Amazing stuff. So another thing that I would like to cover is the README.md. Basically, it's a front face of our open source project. And I personally tend to keep it simple and tiny. And usually I add some like an intro text just to provide some brief overview of a project. Then I add links to the documentation, to the changelog. And then these badges that show the state of the CI, like code coverage, number of downloads, current actual version, and stuff like that. And finally, a project logo, if I manage to get hands on one, but that's usually not the case. Okay, I know. Those badges look good, don't they? Well, there are a ton of websites that actually generate those badges for you, but I've kept coming back to shields.io. It's a very simple service. So you just need to paste your GitHub URL on top, and it's going to generate the URLs for all available services out there. You just need to select the service, copy the URL, and paste it into your README.md file, and basically that's it. Obviously, you can't have a Travis badge if you don't use Travis. So you need to enable the services first and then use those badges. So far, we've managed to configure PHP CS Fixer, PHPStan, Travis, GitHub Actions, and this seems like a massive thing to do at once. And to help you cope with that, there are package skeletons available out there, and they already contain like a configuration files for all those services, changelogs, contributing docs. Basically, this can save you a massive amount of time. And the guys from the League of Extraordinary Packages, they will even allow you to actually release the project, the library, the framework under their organization if you comply to their rules and guidelines. And you can find those guidelines on their website. But I think it's like a list of 10 rules, if I'm not mistaken. Usually you need to have tests, you need to have like a good documentation. Those things make sense, basically. Okay, we're almost come to the end. What we still need to do is to make our package available in the composer registry. Okay, so let's do that. So the last step that is required to actually to make your package library, whatever, available for like the whole PHP community is to add your package to packages.org. So basically you just log into the packages, you paste your GitHub URL there, you enable auto sync with GitHub so that when you tag a new release, the new releases are automatically added to packages, and basically that's it, you're good to go. Packages will automatically scan for new versions, and in a matter of minutes you'll be able to use Composer to install new versions of your library. And basically we come to the end, and just a small summary for the end. I know it's a bit overwhelming, the guides, so don't try to do all those stuff in a single step. I suggest that you check those tools, even find new ones, play around with them, figure out which one suits you the most. You don't have to use all of them, just find the ones that suits you the most. Probably the most significant issue is going to be the lack of time, as you would be busy with your life, with your job, so you don't want to devote like the whole free time babysitting an open source package. So I suggest that you try to devote like a one or 2 hours a week to your open source project. Skim through the open issues, put some comments so that other developers know that you're on to fixing issues, and appreciate the feedback. That's one of the important things. Appreciate the feedback. Try to find out what is working for your users and what's not. Try to improve that in the future releases. And the whole experience of maintaining the open source project will be a rewarding experience, and you will definitely learn a lot. And finally, ignore the mean people that are putting like the mean comments and some ugly stuff on GitHub. Basically, they are not worth of your time. And that's it. Thank you very much. Do you have questions?
First off, thank you, Mario. That was awesome.
Thank you.
From the room here.
Sorry, I can't hear you very well. I have a lot of noise. Can you repeat the question, if that was a question?
It was not a question yet.
I think we don't have any questions here. Thanks for that presentation.
Yeah, thank you very much, Mario. Very, very detailed, informative.
Well, thank you very much for reminding me.
Somebody waving his hands there, and Longhorn had a question.
No, I was just saying good job.
You're just saying good job.
Thank you. Thank you. Thank you, guys.
Yeah.
I still haven't gotten
All right.
the JetBrains license, so if anybody wants to email Chris at atlantaphp.org, let me know. We'll get you set up.
Sweet.
Getting really,
All right.
really like delayed feedback here.
Yeah, sorry. Probably me.
Cool. All right. Thank you, Mario. Thanks everyone for attending. Go get some sleep, man. I know it's pretty late over there, so we appreciate it.
Yeah, 2 a.m.
Yeah, we appreciate you staying up late with us. We always have that problem with the EU people and so forth. So it's greatly appreciated.
Anytime, guys. Anytime. Well, thank you very much, and hopefully we will see you on some conference live. Hope so.
Yeah, maybe next year we could do this live instead of on Zoom, right? At a conference.
Well, I'm in. You can count me in.
All right. Well, thanks. And this concludes this month's edition of Merge PHP. Thank y'all, and we'll see you at the next one.
Thanks, everybody.
Bye.